Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. Been a little bit. I hope you've all had a great week. I've had a pretty good week so far. Kind of funny story though. So, I was testing something on VR, and I need to you can kind of see my room is a little full, and I was I don't know, I did something quick, so I didn't want to have to move stuff around, and I ended up hitting my hand on some of my furniture. So yeah, and it's pretty sore, but I think I'll be able to, I don't know. The reason I say that is because we'll see how long I can type before it starts to hurt too much, but I think I'll be okay. But let's go ahead and get started. So, of course, the last couple days or weeks, we've been working on a tutorial about writing code or HLSL shaders in Unity URP, and so we're going to continue on that today. We're actually on the last section, which is using custom data in shaders. And so a lot of times, a vertex and a shader are basically, a shader can only know about what's on the piece of data that it's working on. So a vertex function only knows about that one vertex, and the fragment function only knows about that single pixel. So sometimes if you need to pass extra data into shaders, you can encode it into some other vertex data streams like the Vertex Colors or extra UV sets. So we'll talk about that. And then you can also set data on the material itself, or even a global. So we'll talk about that. And then just a small section on how to use arrays in HLSL, because they sometimes come up and they work differently than in C#. And then I wanted to talk just a little bit about procedural colors. This is just, using code to generate the final color of a pixel, because so far we've only really worked with textures, and I think it's important to realize that you can basically use any kind of data you want to generate the final color of your material. Usually they're called procedural materials, but same idea. Okay, so to get started, I actually want to make a tutorial, or a showcase scene. We did this for the vertex animation from last stream. Okay, so we'll make a new scene. Let's do, well, I guess we'll do the basic. I don't know what the difference is. Oh, it has a global volume. Yeah, I don't need that kind of thing, so we'll just do this one. Save as. We'll call this Vertex Colors. Okay, so what I want to do for this, like an old PlayStation 1 and Nintendo 64 games, they would use the Vertex Colors to do wetness or wound effects. So a famous example that I know of is on GoldenEye 64. Whenever you would shoot somebody, they would put red vertex colors on on where you hit them, and that would be a blood wound or something. So we're gonna recreate that effect just because it's pretty simple. Maybe we won't be quite so gory in this one. We'll have, I don't know, we'll paintballs or something. Okay, so first what I want to do is copy the MyLit shader folder, just so I don't have to write quite so much. And we'll call this, I guess, Vertex Colored. Alright, and so We can delete some of this stuff. There might have been an easier way to do this. Okay, actually, yeah, let's open it in here. Okay, so it's already shown up. And we'll just rename it here so that way we won't have to recompile every time. So okay, so the shader color. Okay, so I want it, we'll just have a main color and I guess a tint does. Yeah, so yeah, we'll just have color, tint, and smoothness. I'm not gonna do alpha or anything, no normal maps. No custom lighting. Might as well leave the cull mode just because that's sometimes useful. Okay, so then subshader is the same. So forward lit. Yeah, we'll just use the default for the blend and Z right. Don't need any of these. Okay, we'll need most of these lighting effects, so that's fine. Okay, and then we'll rename this to Vertex Color Lit Pass. Okay, so for the shadow caster, we can do basically the same thing. Yeah, we don't have alpha cutouts. Okay, depth only. Depth normals. This is kind of like one of the nice things about Unity's surface shader program is it kind of takes care of all this busy work for you. But obviously that doesn't exist in URP, and also it's not quite as customizable. Although I think we could do this entire vertex colored shader in a Unity yeah, built-in renderer surface shader. Okay. That scared me because the vertex animated was highlighted, but I didn't want to be editing that. Okay. Okay, so that common file, let's rename this to Vertex Colored. Okay, and we're only gonna have the color map. Okay, and the surface will be simple as well. I undid once too many times there. Okay, so I basically just want to set both of these to 0, I think. And the normal map will just always be pointing in the Z direction. No mission. No. Okay, well, occlusion will always be 1, actually. Alpha, always 1, and then no clear coat. Okay, and I'm gonna, oops. I'm just going to copy this and paste it into all of the other passes because it's going to be this. Well, I guess it's actually not exactly the same. Oh, yeah, because this is supposed to be depth only. Okay, well, let's. Take care of this right now. Okay, and then also copy, I guess just this line really. Okay, so here. Alright, so I won't need the tangents at all. And I won't need the UV either. Okay, so yeah, we just pass the interpolated value through here. Alright, and so depth only, we name this to Vertex Color depth only. And we don't need the UV. Because there's no alpha cutout. Okay, and then the forward pass. Alright, so I guess we won't need the tangent vector anymore. So I can get rid of that. Okay, so then we can bump everything up one text chord. We still need all this stuff. Yeah, so basically the only difference is we don't have the tangent vector. And then in here I can get rid of alpha clipping, all these other samples. Oh wait, I think I got rid of the color sample by accident. Yeah, so this. And then no normal maps anymore, and we don't have any custom lighting. Okay, so this should be input. Okay, the tangent to world. I'll just set this as 0, I guess. It should be the identity, but okay, and then the meta pass. I think this is actually going to be the same. And then the Shadowcaster. Okay, so yeah, no cutout, so we don't need that. But I think everything else is the same. Okay, and to save time, because I think we're gonna need another shader like this later, I'm gonna... Well, I was gonna copy and paste it, but I guess I have to do it in Unity maybe. Oh, wrong program. Okay, it's in Vertex Colored Lit Pass. Oh yeah, this should be forward lit pass. I guess I should make sure there's no bugs. Yeah, this should be Shadowcaster. Oh, okay. Oh yeah, here it's gonna complain because I don't have tangents anymore. Oh yeah, in MetaPass there's no alpha clipping. Okay. Oh, I can also get rid of the this custom lighting block. Forgot about that. Oh yeah, and then there's no emission or metallic map. Okay, there we go. So, well, okay, let's make sure that actually draws something. So we'll make a sphere, put it at 0, 0, 0, and then make a material. Okay, and give it the neutral gray for now. Okay, everything seems to be working. Alright, so now, yeah, I'm just gonna copy this folder and we'll just leave this around because we'll just have this really simple shader that I can use as a base, because I think we're gonna have another shader for when we do setting data from materials. Okay, so now what we need to do is basically add Vertex Color functionality to this. And it's pretty simple to get Vertex Colors. It's just another semantic in the attribute structure. So we'll do float for color. Okay, and then we'll need to pass this through. Okay, and then so we'll have float for color. And yeah, it needs to be a text chord because we need to interpolate it. So it'll be text chord 7. And then we'll just pass the color through. Okay, and so the easiest thing to do is just add the color to the surface input. So we can do that here. So yeah, we can just multiply the vertex color and to the albedo. And what I want to do is use the alpha value of the vertex color as like a smoothness multiplier. Let's see, so... Okay, well, let's just try it. Because, yeah, that's how we'll make certain areas look wet, is we'll make it have a higher smoothness. This is my idea, but because this is multiplicative, maybe I need to add to the smoothness here. Because if the base smoothness is 0, then multiplying it won't really work. Yeah, so let's do that. So we'll saturate. might even want to add the vertex colors to the albedo instead of multiplying, but I'm not sure what would look the best. Let's just go ahead and do that. Variable colors use. Oh, right. I have to say input.color. No matching one parameter function. Oh, okay. So for the meta pass, we'll just pass in 0 as the vertex color, because if you're using vertex colors to permanently change a mesh, you would probably want to add them into this to the meta pass. But for this tutorial, I want like the bloodstains or wetness to disappear after a while, so just won't worry about that. Okay, sometimes Unity just kind of freezes. Okay, there we go. Alright, so it's white now because the vertex colors by default are white. Which is fine. See, so what am I? Okay, so if we want to set the vertex colors, we can. There's two ways. You can either do it through Blender, but I don't know if I'll do a tutorial on that. Okay, well, no, I don't think so. We'll just do it through C#. So what I should do. Okay, so let's have. What do I want to call this? I guess Paintball Vertex Colors. I just realized I should probably increase the size so it's a little bit easier for you to see on stream. Okay, so what we want to do here, we'll have a reference to the mesh renderer. Oh yeah, I can't call it renderer because it overwrites something. And basically, whenever we'll use like a raycast to hit the mesh, and then using that we can figure out like what vertex was hit. Okay, so let's have like a buffer, which is just like a place in memory where we save things. So this will be a color buffer. Okay, and so we'll assume that the mesh doesn't change. So mesh renderer equals get component mesh renderer, and so the mesh itself. I guess we don't need to do that. We just need to get the number of vertices. So vertices equals mesh renderer shared. Okay, there's no shared mesh. Oh, right. It's the filter that we need, not the renderer. I always forget that. So, filter. Oh. Shared mesh. Vertex count. Okay, and so then we can set the color buffer to a new. I guess we can just use actual color instead of vertexes. Should be an array though. Okay, and so what I want to do Okay, well, it's automatically initialized to be all black, so we should set. Okay, then we should reset the colors on the shared mesh. Okay. Let's just make sure that this works so far. Okay, we actually will need the collider, so I can leave that. But we'll add this here. If I press play, it should turn to neutral gray because, yeah, the vertex colors have been set to black, so they're not adding anything to the material. Okay, so it seems like, that's what I was wondering, does the data persist between play sessions? I don't. Okay, actually, yeah, we probably don't want to have a shared mesh in this case. So what I can do is we should just use the mesh. This will make a copy of it. Or is there not an option? Okay, so what? I guess we don't actually need the mesh filter then. We should just store a reference to the mesh itself. Okay, yeah. Because we kind of want each object that has this to be able to have its own paintballs. So if we use a shared mesh, then they would all show up on every object. But we can test that out. I'm pretty sure that's how it would work. So in order to make a copy, we can just call new mesh and pass in the shared mesh object. Right? Okay. No. Isn't there an easy way that I can... Oh, wait. Okay, that's not how you do it. You just need to instantiate the mesh. Yeah. Okay, there we go. So this makes a copy of this mesh. And then we can just set the colors on there. Oh, wait. One other thing we have to do. So filter equals get component mesh filter. So first we have to copy the mesh and then we have to set it back on this filter. Wait, how come that didn't show up just a second ago? Okay, well this is wait. Okay. I'm a little confused now. Okay, so I guess this will, just calling this will instantiate it and assign it to this filter, which is what I wanted to do in the first place. I thought that that option didn't show up for whatever reason. Okay. Anyway, yeah, nothing will be different here, but might as well just make sure. Okay, let's move this closer. Okay. So now what we want to do is do some kind of ray cast whenever the player clicks. So the raycaster, let's just make paintball raycaster. Hey Seagull Rush, how you doing today? Okay, so what I want to do here, I'd kind of like it to be like independent of this object. So we could, I mean, we could use interfaces. I think the easiest thing is just to use a Unity message. Okay, so what we'll do here, it's a good idea, I guess, to have serialize field, private, int, raycast layer, or can I just do layer mask? And then if input get mouse button down, so if we hit the click the left mouse button, which is 0, then we'll initiate a raycast. Okay, and I always forget. There's so many overrides for this. Okay, so I guess we mostly just want array and then the hit info. Okay, so camera equals camera main. So start point is the camera green point to ray, and okay, and so it's kind of, these functions are confusing, but so the X and Y is the mouse position, the Z, the mouse position in pixel space, and the Z is like depth in world, or I guess view space. So mouse position green pixels equals our input dot mouse position. Okay, so screen point to array, new vector 3 x y, and then the camera near clip plane. What's the overload? Oh, you can do stereoscopic, but I guess that's actually the ray. Doing great. What's cooking today? We're working on the last section of my URP shader tutorial, and I'm showing how to like pass extra data to shaders from C#. Specifically, I'm going to kind of recreate a technique that was used in like old Nintendo 64 and PlayStation games for like wetness effects or like wounds, but we're calling it a paintball for the specific example. Okay, so hit info. Okay, does that work? Yes, and then it returns true if it actually hits something. Yeah, it should be. I thought this was a good example. Okay, so hit info. Does it have the game object? Oh, it has a collider. So collider, game object, send message. So we'll just say paintball, or on paintball hit, and the object, I think you can only send one object, so we can just send the hit info, and then it can do with it as it pleases. Okay, so then here we should get that message. So void on paintball hit, and then we should get the hit info. Okay, type. Okay, it's called raycast hit. Okay, and then let's just do a debug log. You're trying to figure out how to use shader graph with a graphics buffer struct node in Visual Effects Graph instead of a compute shader. I think you can get compute buffers or graphics buffers through custom functions, I'm pretty sure. But I haven't actually ever tried that. Okay, so paintball hit. So on, we'll say game object name, triangle equals our info. Okay, I think, yeah, triangle index. So we're going to be using this triangle index to set the colors in our color buffer. Probably we should store the triangle buffer as well. Because originally I was thinking that it'll give us the vertex, but no, it's actually the triangle, so we're going to have to like look through it. Okay, well, let's see if it even works correctly. So the raycast layer, we'll just set everything fine for now. Custom function in VFX graph, that would be a gbuffer node. Oh, okay. I thought you meant the shader graph. Yeah, I was talking about shader graph custom node. I haven't even used the VFX graph yet, which is definitely something I want to get to, but haven't had a chance. Okay, yeah, so paintball hit. Okay, unfortunately it's saying triangle -1, which is not... what I was hoping for. I don't know why it says that. Okay, let me see. Unity, raycast, hit, triangle, index. It's only valid if the collider was hit with... oh, that's why it's using a sphere collider, so I need to change it. Okay. That makes sense. I know I'm gonna forget that. So use mesh collider. You want to drive particle position and animate them using the shader graph. That sounds like an interesting project for sure. Okay, it's convex, so that's nice. I don't know if it really matters. Oh, I did this all while playing. By generating a color map for position. Oh, okay. I see. Yeah, I wish I could give you some more tips, but I haven't really tried to do something that complicated in shader graph yet. I mostly just mess with like procedural materials and things like that. Okay, so for some reason, the mesh... still returning negative. Shader graph is way better at debugging visually. It just feels much better. Can't wait until the two are finally merged. That will be nice. I haven't heard anything on that front lately, but that's kind of one reason why I've held off on looking at the VFX graph, even though I know people have said it's pretty cool. Oh, again, I was doing it in play mode. Okay, so one thing, it doesn't seem like this, that the collider actually matches the sphere mesh. And it's still saying the triangle is -1. Okay. This wasn't something I was expecting to have an issue with. Okay, triangle index is only valid if the collider was hit by a mesh collider. On the original triangle indices. Okay, that might be an issue. Okay, well this is kind of a shame because this is messing up my idea. Because they're saying that the mesh collider doesn't correspond to the rendering collider, which makes sense, but they're saying that it doesn't actually return the correct triangle index. You haven't even seen that on the roadmap. Yeah. I'll have to go check into it, but I don't know what the timeline is. Okay, of course it doesn't work with a convex mesh. Oh, okay. So maybe it was I shouldn't have hit this convex button there. Okay, let's try this one more time and see. Just let me left my phone on. Okay, so that was a problem. Just don't turn on convex. Which I guess makes sense because what's happening when you do that is Unity's generating a new collider from the convex hull of points. Yeah, so we don't need to get into that in the tutorial because that's way outside the scope. Text off. Okay, so anyway. Okay, so now what we can do, so we need the triangle buffer as well because we need to basically search through this and find so the triangle buffer kind of like gives you the vertexes that are inside or that make up one triangle. So like if we multiply this by 3, we can get the 3 vertices out of the buffer. So triangle start equals info triangle index times 3. And so basically Unity has flattened the triangle array, so every 3 consecutive values in the buffer correspond to 1 triangle on the mesh. So in order to like get the start point that you will read the vertices from, you have to multiply the index by 3. So the vertex index is triangle buffer I, or triangle start plus I. And then, so we can, with that we can set the color buffer. So the color buffer vertex index, we'll just start off with just red, I guess. And we'll set the smoothness to 1, so it will be shinier. And okay, so now I just need to set the new buffer on the mesh because this doesn't update automatically. Okay, so let's try this out. Okay, and there we go. We got, wherever we press, we get red sections on the mesh. You can see there's some weird areas, but that's just because that's how Unity lays out the wireframe. So you can kind of see here that the pattern follows the mesh's wireframe, and that's because the colors are only stored on each vertex. So here, like this vertex, the color is black, so it will it just there's a gradient between those sections, so it's a good way to kind of visualize the barycentric coordinates as well. Although here you can see there's this hard line, and that must be because Unity on this mesh, these vertexes aren't shared. So I don't know, this is getting kind of advanced, but basically there's multiple vertexes that share the same point, and that's because there's some seam there. I don't really know why there's a seam on a sphere. Probably just because Unity didn't completely optimize this object. Maybe we should use a custom mesh. Let's just create one real quick. Okay. You might already know well, but there's a good thing to look into when you get familiar with VFX Graph. Oh yeah, Kaijiro, he always does such cool stuff. But I haven't seen that specific one, so yeah, thank you for that link. I'll check it out for sure. Okay, so let's just make... I always like icospheres. We could also do a donut. Let's do a donut. Maybe shrink this a little bit. No, I think it was better at 12. Maybe something more like this. Okay, I like those proportions. Just bring this somewhere else. Alright, Seagull. Have a good call. Gotta find my project folder. Meshes, donut. And Unity should, or Blender should save it without any seams, I hope. Okay, let's just delete. Oh, okay. And then we can rotate this however I want. Let's do it head on to the camera. And then add a paintball manager and a collider. Okay, so now it's complaining. Okay, this is a good idea. I'm glad I thought to do this. We need to tell the mesh that read write is enabled. I always forget this step, and people always, it's a common problem that people have whenever we work with meshes in my tutorials. Turn on read write. Oh, it's not using our material. So I was like, okay, we're hitting it, but it's not showing up. Okay, and you can see in Blender, the colors are white by default. But when we press play, they'll turn gray. And so now we can see. Okay, so unfortunately there's still seams. I don't know why. Oh, okay, so the reason is just because if we could visualize normals here, since we can see like hard edges on lighting, the normals are not shared per vertex, and so that's like an easy way to tell that there's seams in here. So if all the points had only one vertex, there's no seams because, or wait, yeah, because the lighting would be completely smooth. So I think you can get Unity to do that. By turning the smoothing angle up and tell it to calculate normals. There we go. So now we can see the lighting is smooth even though the mesh itself is still low poly. So hopefully this got rid of the seams. Okay, yeah, that's much better. That's kind of what I wanted. There's still one right there. Why? I guess that's just the way that Blender set it up. I mean, there's ways that you can get around this. Like, we could search through the entire vertex list to try to find coplanar points. I don't really know if... I feel like that's not really needed in this tutorial. I guess I'll just make a note of it. So maybe it is good that we bring this up. Or not coplanar, co-spatial points is what I was thinking of. Or yeah, points that have the same position, but different data. So is there a way? Okay, so it has weld vertices on, but for some reason, oh, I bet it's because the UVs are different here. So we don't actually need the UVs, but I don't think there's a way that I can like tell it. Yeah, so probably UVs start here and then wind around. So since there's an edge in the UVs, at this point they have to put two vertices at this position. Anyway, it doesn't really matter, but it just doesn't. It just makes this particular showcase not look as cool. Do I want to? I mean, I kind of want to fix it. Let's do it. It's gonna bother me. So what I need to do now is, so once we find the vertex index, I need to like find all vertices that have the same position. So I've done something similar in another tutorial. I don't know. It's just like, it's like, it's not complicated and also complicated at the same time. If that makes any sense. We could just, I mean, we can do something like, this is probably the easiest way. So, shared vertices. I mean, it's basically vertices that have the same position. Don't know what the best name for that is. Okay, let's actually just make this a list, an array of lists. Okay, so the positions aren't going to change here, so we can do something like this. And there's for sure more efficient ways to do this, but I'm just trying to think of kind of simplest and the simplest way to illustrate the problem. Okay, yeah, so we'll just do this the brute force way. Vertices. Okay, so shared vertices I equals new list, and then for each. Okay, let's not do that. For int j equals 0. Okay, so we only have to do, actually we only have to do vertices after this because okay, no, actually, because we do have to check before unless we somehow forwarded. Yeah, so I just want to do, like I said, I just want to do a really simple algorithm here. It's definitely not efficient, but so if I does not equal j, well, I guess it can have its own itself in there. Doesn't really matter. That'll probably make the algorithm simpler. So now we need to get the vertex or the position buffer. We don't really have to save it though. So vector 3 positions equals mesh dot vertices. Okay, what's it not like? Oh yeah, it's an array. So if positions I minus positions b or j, or I guess it'd be vector 3 distance. Okay, so the distance between these points is less than some small number. Let's do something like that. Then we'll say that they're shared position. So we'll add J to this list. Okay, and so when we do that, so we could get the original vertex index out of the triangle buffer, but we've got to loop through every shared vertex. Shared vertex index in shared vertices. Okay, so that's not too complicated, I guess. I mean, there's a more efficient way you can do this with like disjoint sets. But yeah, I don't really want to have to explain all of that stuff because it's a super big tangent. Okay, still doesn't work though. Let's do some debugging. Okay, so debug vertex. Vertex I at positions I shared with vertex J at positions J. Okay. Should probably do a way simpler mesh. Yeah, there's too many here to tell what's going on. So let's temporarily change this to use just a cube mesh. Okay, well, we can leave the glider, it doesn't really matter. Okay, you can see that there's still quite a bit of meshes here, but so vertex 0 shared with vertex. Okay, so it is saying, so vertex, I guess each point should have 3 vertices in common, 1 for each face. And it looks like that is happening. 4, 5. So if I let's have this use the cube as well. Oh, I turned off the mesh filter. Okay, so I think the co-spatial vertices are being read correctly, but it's not setting the color right. Oh, I think it was a silly mistake. Yeah, I'm still using the regular vertex index here instead of the shared vertex index, so yeah, that was silly. Hi, i3. How you doing? Alright, so if I... Oh, right, need to turn this back on. Okay, so now you can see... every point. So I clicked this triangle, so each point on the triangle was set red, as well as any points that shared the position. And so you can see it's a much cleaner gradient. There is kind of some weirdness right here, but I think that's just because of the way barycentric coordinates work. Oh, hey Zach, or ZA3K. How are you today? Anyway, okay, so I guess this works. Let's get rid of this so we don't spam ourselves every time we press play. And we'll add back the donut mesh. I thought it was called Taurus. Oh, I clicked the material. Okay. So now, yeah, there's no seam there anymore. And if I wanted to, I can tell it to just import the normals again. So we can have the low poly look. I don't know if it really makes much difference, but... So now we can see, even though each of these lines in lighting signify that there's multiple vertices at that point, it's still what's it called? It still like colors everything. One cool thing is you can see the different smoothness where we've hit as well, because it's much shinier in the red sections. Okay, so now one thing I want to do before we go any further is if I duplicate this object, okay, that's fine. If I paint one, it should not show up on the other. Okay, and that's good. I just wanted to make sure. Whereas, let's see what this does. If I use the shared mesh like I was before, they should share colors. Yeah, that's because, okay, and it does something even weirder because each script has its own independent color buffer. The one that I click most recently gets set on both of them. But anyway, just wanted to illustrate that. And yeah, having shared meshes in general is better, but in this case we want each mesh to be independent so we can set colors independently. Okay, and since we set the shared mesh, it also permanently colored the mesh, which I don't really like. I think to reset it, I could just go back into Blender and save it again, and it should overwrite the colors. Yeah. So what else do I need to do? I guess... Oh, you made Bro die. You're trying to figure out why you were following me. Oh, thanks, Zach. Yeah, I'm really proud of that game. For a long time, I've wanted to remake it with better, like, production values. I don't know when I'll get the chance. But... yeah, I think it's one of my favorites that I've... because I used to do a lot of game jams, and that was actually a game jam game, and I think that's one of the favorite ones I've done. When is the next Ludum Dare? I might try to enter again. I haven't done one in like a couple of years now. Usually they always happen when something else is going on. Okay, April 4th. I think I actually do have something on that day, but I don't know. We'll see. I guess I mean, I don't really need an excuse to do a small game like that. I can do it for any reason or any time, but okay. So what's next? I guess I want to do a random color because that'll look cooler than having just red. so does Unity, I forget, do they have the hue saturation value? I think it's called like color utils, color utility. That's not. I think they have some tool. Let's see, Unity hue saturation value. Okay, it's just in the color class. Okay, so what I'll do is just do a random hue, and we'll just do full saturation and value and see how that looks. It's gonna be pretty garish, but that's fine. Okay, so I should actually do this before, yeah, because this color will be shared by all vertices that we've hit. So color equals that, and then I want to set the alpha to 1 because I want it to be shiny. Okay, and try this. Okay, that's funny. I mean, you know, randomness, but it's funny it did a bunch of pinks in a row. Okay, but we can see now we've got actual multicolored paintballs. Cool. All right. Okay, so what else do I need to do? Oh, I kind of like the paintballs to... Well, I was trying to think of another thing, because I want to show off that you can use other UV sets also. So I thought, well, why don't we just put the time that the paintball was hit, and that way we can have it fade out. So, okay, so what we need to do here is we'll also have like a time buffer. Am I painting in the editor? Yeah, pretty much. I want to show for the tutorial how you can pass data from C# to shaders using Vertex Colors. So I thought it'd be cool if it was like a, I don't know, some kind of paintball. Because in like older PlayStation and Nintendo 64 games, they would use this effect to do like wetness or gunshot wounds or stuff like that. So I thought I'd do paintball because it's a little bit more lighthearted. Okay, so for the time buffer, vertices as well, and oh, except this is a vector 4. So mesh UV4. Okay, so you can only do a vector 2 that way, but I think we can do set UVs. And so the channel will be 4. Okay, no, actually it'll be 3 because it's 0 base. Okay, so time buffer. I should actually use set colors here as well. Okay, so let's also do the time value. So vector 4. Oh, what am I doing? Time equals new vector 4. So for this, I guess we'll put the start fade time and then the complete fade time. So let's see. Let's do a couple properties here are serialized fields, private float, I guess show duration, and then fade duration. So we'll have our start time, or I guess now time is time dot time, and then okay, so now time plus show duration, and then fade duration, and then the other two values we don't really need. So then time buffer shared vertex index equals time, and then we'll set the UVs. Okay. And then on our forward lit pass. Okay, so we have the color here. Okay, so float for colors. Let's do Vertex Color equals input color. And then I also, I need to pass through the time data. So, yeah, you can use these other text chords. I think models can have up to 8 sets of UVs. But I don't think all graphics support it, so, but you usually are safe enough to use text chord 3. And then, so we'll only use the first 2 values of it, so this will be, let's just call this color fade time. And then in the vertex function, we can do output color fade time. Oh, right, and I didn't rename this, so I guess this can actually just be a float 2. Because we throw out the Z and W values. And yeah, we can just pass this through. Okay, so this is the right. I guess we can use smooth step. Yeah, I think so. So input color. Oh wait, no. So we do it like this. Equal or times smooth step. Forget the order. So smooth step is kind of like interpolation, but it will basically range between 0 and 1, or return between 0 and 1 based on the bounds you give it. I'm trying to remember the exact syntax. Okay, so the minimum range is the first value. It always confuses me because it's like opposite of the lerp function, or there's something like that. Okay, so time or color fade time dot x, color fade time dot y, and then we can use the actual time, which is passed to us from Unity in this underscore time dot y variable. What's a UV? It's like on the mesh. I'm trying to think how to explain it. So they're kind of like coordinates on how you draw textures on a mesh. So every vertex has like a data, and it tells you like what pixel to draw a specific triangle. So it's kind of like, you know how when people take like a map of the globe and try to put it onto a paper, it's like that, except you're trying to map like a flat texture onto a 3D mesh. Okay, so why did it do this? It's a kind of cool pattern. Is that, maybe that's just the way that the UVs are set up on this particular object. Yeah, that must have been it. So oh yeah, you could see it kind of swirl around, and that's because of the time effect. But I forgot to set the duration. So let's show it for 3 seconds and then have it fade out. And just see how that looks. That's pretty cool, except I think it's starting to fade out immediately, which is not what I wanted. Okay, so I probably got some math incorrect. Oh. Yeah, so it starts fading after the show duration, so I need to add this into there as well. You need a clamp on the start time. That might be another thing as well. Let's try this though. Okay, so now it's reversed, I think. Kind of cool effect, but not what I'm going for. So probably what I need to do is just do a 1 minus here. Okay, there we go. I think that's correct. Kind of cool how it fades from the edges. Okay, so this is a problem. I don't know if you could tell, but it's like fading, or the color is interpolating between objects, or between colors that don't exist anymore. That's just because the color data is left over in the mesh, even though it's disappeared. Let's see. There's not really an elegant way to fix that, because what I need to do is basically whenever we hit a paintball, I'd have to loop through every vertex to see if the fade duration is gone, and if it is, I have to set it back to 0. Okay, well, I guess let's do that. It kind of makes this not as efficient, but okay, so color buffer length. So let's float erase time equals basically if, well, no, I don't have to do that actually. It's just if the fade time, like if this value is less than the now time. It's also still fading immediately. Oh yeah, I think you're right. I need to fix that. Well, the problem is I have to like, but yeah, you're right. I should fix, it's still fading immediately, so I should fix that first before I move on. But the problem is like when I Like if I click this, and then this disappears, when I click a neighboring triangle, it's still merging with the purple color that used to be there. Okay, that wasn't a good example because the colors were so similar. But so in order to get rid of that like phantom color, I have to like loop through the rest of the mesh and clear out old values. But yeah, so it's not. Yeah, so I guess I do need to do a clamp. I thought that smooth step might clamp automatically, but I always forget the specifics. So what I'd have to do is just do saturate like that, and so this saturate clamps a value between 0 and 1, which is what we want right there. So now hopefully it should show. Oh no, it's still not doing it correct. You're lost, you never used Unity, so you'll probably head off. Thanks for showing cool stuff though. No problem, Zach. Yeah, you're kind of like, this is like the end of the tutorial, so it kind of expects you to already know some of this stuff, but anyway, I hope, I'm glad you enjoyed what you did see. All right. Oh, this is the wrong project. Okay, so the X should be, so it's oh. Okay, this might actually, I think this is also because the time is being like interpolated between vertices on the mesh. That's interesting. Don't know. There's not really a way to fix that without doing something like, I guess you can turn off interpolation, can't you? I don't know. That's kind of, let's see. Shader, turn off interpolation. Forget the keyword for this. Yeah, I think this is no interpolation. I don't know, this might look weird too. The way it is now, I mean, it looks okay, although it's not exactly what I had in mind, but I don't think the problem is, so I'll just show it. So when I click here, like the time is still 0 on this one, and it's being interpolated between these 2 points. So the fading is a little inconsistent. I don't know if it really, I mean, it still looks okay. But yeah, it's not exactly what I wanted. Probably what I should do is set the time values like for the entire mesh. If it's not, like if it's let's see. I don't know how to explain it besides just doing it in code. Okay, let's try the no interpolation thing first, but I don't think this will look much better. So okay, you can set for no interpolation so it won't interpolate this value. But it's not supported by all. I don't know. Yeah, see the problem here is that the fade, like, it makes this triangle, it like reintroduces seams because the time is set to 0 on these other sections. I don't like that. I don't really think we can get this perfect. Like if you wanted it to be perfect, you'd use decals instead of this like kind of vertex color way. But okay, so for anyway, if the time buffer for this vertex has already like expired, so the y value is less than now time, so it's hidden, then we want to set the color buffer to black, and then the time buffer to our current animation time, just so that it will, wait, I can't do that. So that it will, I think, animate a little better. But let's see how this looks. Okay, yeah, that's definitely more what I had in mind. And there's no phantom colors anymore. So if I click here, okay, so it reset that, which was... Why is it? I don't know why it's affecting those. I guess because... Oh, okay, so what's happening now is... Yeah, so when I reset it, like it's not affecting the colors that were fading, but colors around it get set to our vertices around it get set to a time like afterwards, so that's why it was like fading outwards, which looks weird. I guess what excuse me, what you could do is just set the entire mesh to have the same time buffer, but in that case, why even have a time buffer? Just set it on the material. So I think I'll just do this, and some of the time things are going to look a little strange, but I don't really think there's a way to fix it elegantly, and this is just really a kind of proof of concept, so it doesn't have to be perfect, but yeah, there's some kind of, it's because of the time fading. Okay, maybe I just... Maybe this time thing is just not going to work out. I think if you wanted to do that, you'd have to... If you wanted to do it and have it look good, you'd do it with decals, which that's what a more modern system would do anyway. But see, the problem now is that these vertices, their time value is set so far back in the past that when I click, it's it's making it look like there's seams again because it just interpolates so far backwards. I guess what we could do, well, no, I was gonna say we could like clamp certain vertices to a certain distance backward, but that would bring us back to that problem we had a second ago. And there's no way that the shaders can do that because they don't have knowledge of the entire triangle, just one vertex or pixel at a time. So, okay. So I'm tempted just to get rid of this color, this fading. Maybe this can be, this will be the example of how to set object or set things per material. But now I wanted to show like how to use the other UV sets, but I can't think of any other thing to add in there. Or maybe I just leave this as like showing some of the drawbacks of the system. I mean, you could probably get it to work, but you'd have to make the code a lot more complicated because you'd have to start like searching neighbors to see like if the time in a certain triangle, like you'd have to store time per triangle instead of vertex. And then manage the interpolation kind of yourself in C# to make sure none of those weird artifacts happened. Yeah, I'm just thinking about if I want to try to do something like that, or I don't even know if it would look good. Or am I happy just kind of like showing off that you can do this kind of thing, but you'd probably just want to use decals. Because it's not like this tutorial is really trying to show this, like how to do this paintball effect. It's kind of just showing like how you would pass data to shaders. But I think it actually looked better without the time fading, because with it you start getting all these weird shapes. Okay, yeah, I think I'll just get rid of the fading. Although, kind of needed it for this phantom color thing. Oh wait, oh, okay. There's not going to be phantom colors anymore because, yeah, the colors don't fade out, so. Okay, well, yeah, it gets rid of that problem. Okay, so what can I do to show? I mean, I guess I don't really have to have an example. I could just say that, yeah, you can also do this. Oh, what's going on here? Oh, I didn't update the shader. I can just say that you can also pass things through these more other text chords instead of just vertex colors. Okay, so that does look better. Yeah, sometimes trying to click on the scene tab, it's not letting me. Okay, yeah, it's just, I don't know. Sometimes Unity just, the UI freezes, I've noticed, in 2021.2. Okay, let's, I mean, I can think of other, like you could use the other, I mean, the text chord to maybe like indent, but I don't really want to do vertex animation again because we already did that. But I guess that would be the pretty simple thing. Actually, wait, I don't like that because then you can't. There's no real good way to, like if I just used UVs to like offset vertex positions, there's no good way to also offset normals. We'd have to like calculate it. I mean, I guess we could calculate it here, but at that point, why not just set? Yeah, actually that's true. Since we're setting this mesh data, why not just set the new positions here? Okay, so I guess, yeah, I guess I don't really have to. It'd be cool if I could show like some example to use both, but I can just say you can also use other text coordinates instead of the vertex color if you need to pass more data. Yeah, I guess that's fine. So, are we done with this then? I think so. Okay, so the other part of this section is I wanted to show like these material set float and shader set global. So what I'm going to do here, I think, is something similar, except instead of when we click setting vertex colors, we'll actually like set a position on the mesh and then use that to do some kind of pattern. Okay, so that's why I'm just looking at the wrong project again. So that's why I had made this copy here. So let's rename this to, I don't know, wave front. I don't know, because I think I'm just gonna do like sine waves from the position that you pass. So Okay, so we're not actually, this time we won't have a texture because it's going to be procedural color. But yeah, I guess we'll have a background color and then a wave color. This will actually be, we'll have like a peak color and then a trough color. Oops. That's how you spell it, right? I know English is so weird and you say that prof instead of prow, but let's see. That's the term that they use for waves. Oh yeah, so crest and trough, but okay, I guess we'll do that. Okay, so this is all, I think everything else here is the same. Oh, except I need to have all this refer to the correct file. So this is like, I don't know, probably the biggest drawback to using HLS cell shaders is you have to do like all this busy work kind of before you can get your shader up and running. But unfortunately in URP there's not really a way to get around it unless you had, I mean, this is all so simple. You could probably write, well, not probably, you could definitely write a tool that would generate all this stuff for you, which is actually not a bad idea. Okay. Alright, so again, we don't have any textures, so we don't have to do all that. We just have background color and crest color and trough color. Okay, we'll still have smoothness. And so here, I'm just gonna pass the albedo, or just pass the color, because we're going to generate it procedurally. Okay, I think all these other passes are the same, so the forward lit pass, you don't need the UVs anymore. I guess we can still do... We'll still have light maps and everything. So we still need normal. Don't need UVs. Hi, Milk Drinker. Just popping in to show support before working on your shaders. You love the vids. Keep up the great work. Oh, thanks a lot. I hope your shader programming goes well. Okay, so get rid of UVs. What are you working on if you want to explain a little bit? Alright, so yeah, no color textures. I think I got rid of all the UV stuff. So we still have light maps. Okay, so we don't have any texture data, so I can get rid of that. And this, right now I'll just return our input white. Okay, so I think that's all fine. Let's make sure there's no... Okay, there is an error. Wave. Oh yeah, so again, this should be waves forward let pass, and I think I did the same thing with the Shadowcaster, so Shadowcaster pass. Usually doesn't. It involves a lot of fishing through old NVIDIA articles and GitHub pages. I definitely know how that feels, so... But yeah, hopefully it will go well for you today. Yeah, so again, we don't have UVs, so I can get rid of all that. And the meta pass is going to be really simple. Again, we don't... Okay. I'll just pass 0, I guess. I don't know. Maybe we need the UVs for the meta pass, but I don't think I have to pass it through, but I'll just need to pass it to the visualizer. No color sample. I think that's fine. Oh, I guess we need to pass. Oh, I guess we can actually just pass the background color, can't we? Background color. Okay, which is probably what I should use here for the time being. You're working on developing a GPU instancing solution with prefab painting since SRP terrain details in 2020.1 is so garbage. Yeah, I can... Yeah, the little bit I have used, because I looked into it a little bit for my grass system, and yeah, it's not the best, but we plan on adding URP support once the base is done if you're interested. It's mainly a free alternative to something like GPU Instancer or Nature Renderer. That does sound pretty cool. Yeah, feel free to send it to me and I'll take a look. And hey Seagull, I hope your call went well. But yeah, that sounds cool, Milk Drinker. Okay, so let's test. Oh, no errors, that's good. So let's move to a new scene. Great. Save as. This will be just waves. Okay. Oh, sometimes it does that. I don't know what that's about. But yeah, it's actually saved fine. And we'll create a sphere. Move the camera a little closer. And actually, yeah, the sphere needs to be at the origin. And then we'll make a material. Waves and set it to the new shader. You set the link in chat, but I don't know if it went through. You can look up Milk Instancer 01 on GitHub if you're interested. Okay, yeah, I can see it, but the moderator removes links. But here I can. I think it'll let me post them. So yeah, if anybody wants to check out Milk Drinker's project, there you go. Okay, and then set this to waves. Oh yeah, I was gonna say it's still gray. That's because I haven't actually set the material. we go. And then if I change the background color, it should adjust. So we'll leave it white for now. Okay. So what I want to do is basically wherever I'm going to have some position that we'll set in C#. And from that position will emanate waves. So I guess I need a couple more. I need like a frequency and a period. Okay, I guess frequency, and then I guess that's it. Yeah, just frequency. I guess I'll need a scale, huh? Which would be like the distance from the point. And this is a float. It's a wave frequency and wave scale. So we'll set this to 1 for both, and then I need to add this to the common file so that we don't break SRP batching. Okay, and then so we could have a property here for like the wave point or origin point, but since we don't really want this to save between like uses, we don't really need it. So we can just define the variable. I don't know. I'm curious. I don't know if this will break SRP batching. Okay, we'll try it out. So this is wave origin. Custom culling, now you won't have to look for the reference. Oh yeah. Yeah, that is custom culling can be pretty complicated, but system comes from reference objects. Oh cool, data streaming. Alright, so what was it? Okay, so we need to calculate the wave color because I have to pass it to the surface function. Okay, so we have, I guess we'll get the distance from here to the wave origin. So distance to origin equals, there's a distance function, I'm pretty sure. Origin, and then this, the position of this, excuse me, fragment in world space. Okay, so I think sine starts at 0, so we'll use the sine wave. I always get them mixed up. Okay, sine 0 is pi. Okay, so I actually should do. Oh wait, no, sine 0 is 0. Okay, I was misreading that. From there, it's a matter of making it interfaceable and adding USB support. Yeah, hopefully, well, since you have it working in the SRP, hopefully that won't be too difficult to do. Alright, so the distance. Alright, so I guess the wave is sine distance to origin times, okay, the wave scale plus time.y times waves frequency. Okay, and then we'll choose the color based on interpolating between them. So float 3 wave color equals. Okay, so we'll interpolate between. Okay, yeah, combining 3 colors is always confusing to me, but so lerp. Okay, and I always forget the order of the lerp arguments because it's different than smooth step, I think. So, oh well, no, not this time. It's XY then start. Okay. The main issue is generating an HIZ depth texture. For HDRP, you're able to do this with custom passes, but URP doesn't support that. Oh, okay. You could maybe do it with a renderer feature, but I don't know if I'm completely sure of what you're trying to do, but okay, so anyway, we have the background color and then the crest color, and then we'll take the positive part of the sine wave. And then for the trough, we'll interpolate between the wave color and the trough color. Yeah. And then, but we have to do like negative, saturate, negative wave. Yeah, so if the wave is -1, then saturate will give us 1, and so then we don't. Okay, so we don't do another negative. Okay, so let's see. If it's 0, then this will return background color, and this will return the wave color, which was the background color. If it's 1, this will return the crest color. This will be 0, so it will return the wave color, which is the crest color. If it's -1, this will return. This will be 0, so it will give us background color. But this will be 1, which will give us a trough color. So I think that's right. Okay, and then I just need to add an alpha to it, which will always just set to 1. Okay. So does the shader break SRP batching is what I want to see. Okay, it is compatible. I was curious because I have that variable that's not part of the property buffer. But I guess that's okay. Okay, so we should already get some waves on it. But I think the problem is the colors aren't set up. So let's do crest, blue, prof, red. Okay. And if we press play, it'll just alternate between blue and red. And that's because the origin is set to 0, which is in the middle of the sphere. So if we move this, yeah, you can start to see it. Alternate a bit. Okay, so then if we increase the scale, then it will depend more on position. And then if we set or change the frequency, then the speed should increase. Okay, so that works exactly how I want. Okay, so now we need to do the part where we set the wave origin by raycasting. For that, we'll do another C# script. Okay, so this is called, I guess I could just rename this to Raycaster instead of Paintball Raycaster. but we'll call this Wave Origin Manager. And okay, let's just rename this to just Raycaster. Okay, and here it's actually pretty simple. Okay, so instead of all this stuff, we really only need the material. And we can get the material from the mesh renderer. So if we get the shared material, actually wait, I want to test this. So normally when you get the shared material, anything you set on the material will actually persist between plays, which is kind of annoying if you're using a Git, like a Git project. Okay, so we don't care about the triangle anymore, we actually want the position. But since I didn't define a property for this float that we're going to set, I think it won't be serialized, which is good. Point? Yeah. Okay. So all I have to do is set material, set vector, wave origin, info point. Okay, so let's see. All right, so this is called on-ray paintball hit. Let's just rename this to on-ray cast hit, so it's generic. Okay. So now, oh, well, nothing happens because I didn't set the script on here. Oh, and I don't have a Raycaster object in the scene. Okay, so it doesn't show up, I think, because I renamed the file without renaming the class. Okay, there we go. So we'll set it to everything. Okay, there we go. Okay, so one funny thing is that it's actually seems like the waves are moving towards the origin, which is not what I wanted. So in order to fix that, we just need to set the scale to negative. Okay, so unfortunately it does still save between sessions. So I don't think it actually matters. Is it stored in the material though? Okay, so you can see. Wait, that's interesting. All this stuff is left over because we don't have a base or a bump map, but it's left over from when we were using the standard shader. Let's see, so in colors are vectors. Okay, so it looks like actually it's not saved. Although this stuff seems out of date. Maybe it's because I haven't save the scene. Oh. Okay, so when I save the scene, it reset. Let's see. Thanks for the follow. Okay, so background. Okay, so the crest color has been set to custom values, but okay, well that's good. So since we didn't set the origin as a property, it doesn't get saved to the material, although it does persist between sessions. But I suppose if whenever we save the scene, it gets reset. Or like if I switch scenes and then came back. I kind of want to make sure this works still since I renamed those functions. Okay. Okay, so yeah, when you switch scenes, it's gone. Whereas if I had set it as a property, then the value would have persisted. Okay. So the other thing we can do is we can also have a number of points. Okay. I don't think I mean, I was gonna say that I could make another shader for like an array of points, but I don't really think it's that big of a deal. Where is it? Oh, right there. So if I turn this into an array of float threes, okay, so this will actually throw an error because you can't just have an array without a length in HLSL. Oh, actually, yeah, it throws an error because it's a syntax error because the array symbols go after the variable name. But yeah, so it's saying it's missing implicit initial value. So one thing we should do, let's do wave number. Let's see, max wave number, and we'll set this, I don't know, 4. Okay, so now if I throw an error, it's gonna just say that there's no version of the distance function which takes an array. You can't even, well, no, you can't pass arrays, but so now what we need to do is define the wave color here. But what I actually want to do, I don't want to, well, we could do it a couple ways. We could like add all the wave colors together, but I actually want to just add the waves together so we can have some like interference. I think that will look cool. So then we'll loop for int I equals 0, I less than max wave number. Let's rename this. Oh yeah, we can't just do that in HLSL. Let's rename it to max wave count. I think that makes more sense. Oops. Okay, I tried to press undo, but you can't undo in this. Okay, there we go. So that's up to date. So all I have to do is just move these in here, and then instead of just setting the wave, we actually will add to it and then generate the wave interpolated color there. Okay, so now still a problem. Oh right, so I've got to do this. And I guess it should be plural now. So it should be wave origins. Okay, so now it works, but all of the waves are in the center because they're all 0. So the origin manager now needs to keep a buffer of wave positions. I don't know. Let's see. I'm not sure if it'll let me use a vector 3. I might have to upgrade these to vector 4s. And unfortunately, you can't set like the max number of waves. Like you can't grab that defined value from a shader, so you kind of have to keep them synchronized, which is a little annoying. But oops, we'll just say 4. Okay, and we'll have like the last set. And instead doing that, we'll do int set origin index equals last set origin plus 1, and then we'll do the modulo, which just basically it gives you the remainder of dividing by the next number. So it's an easy way to kind of like loop back around to the beginning of an array. Okay, and then wave origins set origin index equals info dot point, and then instead of setting a vector, we have to set a vector array, which I think, yeah. So what does it take? It takes a list of float 4s or an array of float 4s. Okay, yeah, so I have to use float 4, which is, I guess, okay. Except now I need to make sure this actually matches the values in the shader, because these are set to be a float 3. So yeah, I have to change that to a float 4 and change this to use the XYZ position. So the W coordinate is kind of just left out there without any use, but we could map something into it if at some point if we needed to. Okay, let's see. Okay, so it's not updating for some reason. Okay, so... oh, forgot the S. I knew that was going to happen. That's another annoying thing about working between C# and shaders, is you have to make sure those strings match up. Okay, yeah, there we go. Except it doesn't look right. Oh, I think I need to do this. So we have to cache the last set origin. So I was just resetting the same one every time. And the reason it looked weird is because it was interfering with the waves from the center of the sphere. Okay, there we go. So there's a cool little interference pattern. Yeah, that looks pretty cool, actually. All right. So, okay, I don't think there's any more bugs or anything else to do here. So yeah, basically this was just to show how to set vector arrays from C#. other, I can set things in, or set things on the material itself. And then what else? Oh yeah, procedural colors. Are you working on the sphere clicker thing? Well, I've moved on to something similar, but yeah, now we're basically creating waves from where we click on the sphere. The one that I was working on before you left, I did finish that, which was basically just, you know, paintballs. But yeah, so this is all done. Okay, maybe we should just use our donut as well here, because it kind of is more interesting than the sphere. Or I could use both. So the donut, I need to remove this one and add the wave. And then give it material. What kind of games do I usually work on? Well, for my job, I work on a VR golf game called Golf Plus. But like in my free time, I basically make all kinds of games. But actually, I haven't really gotten to work on like any personal game projects in quite some time because my tutorials take up most of my like free game dev time. Not that I'm complaining, but okay. So the interesting thing, these share a material, so you can see. But when you click on one, it does affect all of them, even though they have separate grips. So in order to change that, we would have to let's see, we'd have to use just the material here instead of shared material. Oh, I'm sorry, Milk Drinker. I didn't see your first comment. What got me into game development? I've actually just pretty much played games my whole life. Oh, it still is not working correctly. So when I went to college, I took programming. And so yeah, that's kind of how I got started and like professionally game development. I've just always loved tinkering with with graphics. I remember like one of the first engines I ever worked with was RPG Maker XP, and that's like a sprite-based engine. I don't know if anybody, I'm sure people have used it, but maybe not anybody here. But anyway, and I would like make all kinds of like fancy VFX using sprites. I remember I made like this firework thing that was pretty good for the engine, I guess. And yeah, from there I just learning a bit more about shaders as I go, until I realized that was kind of my favorite thing about game development.
I'll tell you the truth.
Okay, so how come? So I should be instantiating the material here, but it seems like when I set the vector array on the material, it also sets it on the other one. Okay, so do I need to instantiate the material? I thought that that's what the material callback did. Actually, like it's not working when I click on the donut anymore. Why is that? Any particular reason why you use URP over other render pipelines? You have to naturally assume it's related to the VR development and assume it's for the Quest 2. Yeah, that's correct, Milk Drinker. Actually, I started using URP even before I got hired. And it was mostly because when I was looking to start my YouTube channel about shader tutorials, I just kind of went with the one that I thought would be, I guess, have the widest. Oh yeah, thanks for the follow. I guess interest from users, and I went with URP mostly because it works better on mobile platforms, which I know a lot of people develop for. At some point, I want to work more with HDRP because I know that Unity is kind of pushing it, and well, it also just has a lot of cool stuff. So I don't know when I'll get to, because yeah, it's like something I'll have to check out myself. But and last time I did a poll, most of my viewers weren't very interested in HDRP either, so I don't know. But at some point I'd like to look into it. Okay. And then of course there's like custom render pipeline stuff, which I think would be really interesting to work on at some point, but I don't know, that's like even farther down the line. Okay, so anyway, how come I should be setting it on the material, but it doesn't seem. Maybe I need to do something like this. I thought that when you called the material it did this automatically, but it seems like for some reason when we click on the donut, nothing's happening. What's going on here? Because I said wave set on donut and position, it gave the right position, and then I'm setting the vector on the material. But for some reason it seems like the material is not being used by the donut. Okay, let's do. You shouldn't have to do this, but I don't think I spelled that right. Instantiate. Unless it just doesn't let you set arrays per material. Okay, well now it at least works when I click the donut, but they're still sharing. Okay, so you must not be able to set arrays per material. Okay, let's test this out. I'll make another waves for the donut, and this one will have different colors. Purple and green, it's fine. And now if let's remove, I don't need to do all this instantiation anymore. This didn't work anyway. So we'll just use the shared material. New material, render material. That should have been the same as the instantiate, but I guess I'll try that in a second. Okay, I guess, yeah, so now these are definitely two separate materials, but it seems like you can't set arrays. Like, arrays are always global, I suppose. Like, you can't have per material arrays. So if you wanted to have material arrays, you'd have to have offsets on the material and say each object reads from like 1/2 of the array or something. So it's possible to do, but I think a little outside the scope of this tutorial. Hey Adam Toot, thanks for coming by. What's going on? I'm testing out the final portion of my tutorial, where I'm learning, or not learning, I'm researching about passing custom data to shaders from C#. And right now I'm doing kind of like this wave shader where you can click on a mesh and you'll generate waves from that position. Okay, wait. So does it not work anymore if I click the sphere? Okay, there's definitely some weird stuff going on. Let's try if just setting shader set global vector array. Okay, well the thing here is that each is going to have its own array, but let's just see if this works. Looks cool, but how easy is the formula? It's not too bad, really. Let's see. Basically, you just take the distance from each position, and then you add together a bunch of sine waves where the input has like a scale with the distance and then a time with a frequency, and then you just interpolate between 3 colors. Okay, let's see. So I don't know. Okay, so at least now it works if I click on the circle. But now when I click here, it's going to reset because, yeah, each manager has its own set, has its own array. So I guess if you wanted to fix this, what you would do is you would just have one, like a singleton that held the wave front or the wave origin array. Okay, but let's see. Let me look. Unity set vector array per material. Okay, so sets a vector array property on the material. If a vector array property with a given name already exists, the old value is replaced. The array length can't be changed once it has been added to the block. If you subsequently try to set a longer array into the same property, the length will be capped to the original length. Okay, that's fine. If you set a shorter array than the original length, the values will be assigned, but the original values will remain beyond the length. Okay, that's fine. Array parameters are not exposed in Material Inspector, nor serialized with the material asset, but they can be set and queried. Okay, so this makes sense, but it seems like from my testing that you can't set it per material. I don't know, which would, based on that documentation, would, I would assume that that is a bug. Let's try this one more time. Okay, so then renderer.material equals the material. Okay, and yeah, now I wanted to set the vector array on the material. Where in the shader did I define the wave origins? It's just in the shader body, the forward lit pass. I don't think that arrays can go into, yeah, it's right here. Maybe it has something to do, oops, this is the wrong file. I could try to put it in this constant buffer, but I don't know if you can put arrays in here. I guess I can try that. Why did I just use material instead of shader material just to instance new? Well, I did that before, but it didn't work. So I'm just trying all different things to see if I can figure out what's going on. Okay, so now it at least works when I click the sphere, but you can see it's global. And now it doesn't work when I click the donut. Okay, let's try placing it in the constant buffer. I guess I should have taken the define as well. Okay, so at least there's no errors. I wasn't sure if you could do that. Oh, okay. Now it works. So I guess the problem was probably something to do with the SRP batcher. I just had to place it in the constant buffer. Okay, well that's good to know. And to make sure, let's make sure that our shader is still SRP compatible. Okay, it's not compatible. Unity per material variable is not declared in the shader property section, wave origins. Oh, okay, so the problem now is that the wave origins array, like everything in here must be a property, a serialized property, but we can't add arrays to this property list. So now this won't work with the SRP batcher. So I guess it's kind of a, well, that's a shame. I don't know if there's a way you can fix it. I guess since the array is constant, you could have just 4 properties like wave origin 1 through 4. But that's not very elegant. And this part of the tutorial is trying to teach about arrays anyway. So I don't know what would be best for now. The SRP batcher can be annoying to work with. Yeah, I think we've just come upon one instance of that. Well, at least, let's see. So, I mean, I guess at least now we can have different waves per material. And I guess I'll just make a note in the tutorial that this invalidates the SRP batcher, and if you don't want it to, you can just move this out like that, and then it should work how it was before. You don't know much about shaders, but for arrays you've used uniform arrays. That's true. I think that the uniform is like explicit or implicit here when you just define a variable outside of any scope. So it's kind of the same. Might be a dumb question, but what about structured buffers? Oh, I could use that for sure, and that would fix this problem, but it's just a little outside the scope of what I wanted to do in this tutorial. Okay, so now, yeah, when you add it outside, it doesn't work when you click the donut, and I think that's just because the sphere gets to it first. Okay, so anyway, okay, so if I'm using, guess it just depends like what version I want to go with. So I guess at this point, if you're going to have it outside, there's no reason to even set it on the material, so you might as well just use the set global array. So you'd want this version. Okay, so you want this version if you're going to break SRP Batcher and you have to have the vector array per material. You want this version otherwise. Okay, now here is the only other difference. Okay, let's just do serialized field. Private bool. Per material array. So if it's a per material array, we'll set it like this. Else like this. Okay, well the other problem now is that if it's a global array, then we should also use a static, like only one manager, because we need them to save the wave origins. So I don't know, this is getting kind of complicated. Okay, let's not deal with that. I think, I don't know, just for the tutorial's sake, I don't want to get, like, doing all that stuff with C# doesn't really help learn shaders. Okay, so we can just use the shared material either way. And I guess I'll just make a note about all these, like, discrepancies in the tutorial. But how do I want to save it? I mean, the set global vector array is probably the most efficient way to do it. And okay, so we can put array here for per material waves. This will disable the SRP patcher. Okay, so let's just make sure this still works. You don't understand why using serialized field and sometimes public, like for me, if a variable is exposed, it should be public. Maybe there's a secret. It's mostly just my style of coding. I don't really like to use public variables pretty much ever in classes, just because it seems like, you know, how do I say it? I guess you're like opening yourself up for bugs, because other classes can just set any value in there, which might not be specifically what you're prepared for. But yeah, there's no reason, I mean, not really any other reason to not use public. It's just kind of how I program. Yeah, it kind of encourages, I guess, not clean code, because some unrelated script could come in and just set that value. Okay, so this doesn't work really with two separate objects because they have different vector arrays, but I think it's fine. I don't really, for the tutorial, it gets the point across about the shader, which is the main thing. Okay, so let's see. Now that we've finished with that, it's time to go and write up the tutorial. But to be honest, I've already been streaming for about 3 hours and I'm kind of hungry, so, and this is a good stopping point, so I think I might just call it here, and tomorrow we'll write the text for the rest of this, and if we have time, it'll be time to go back and do the second draft for the entire script. So that will take a while, but oh gosh, I'm a little worried because yeah, I've broken the tutorial up into 3 sections. The first and second are 21 pages. Okay, looks like the third won't be quite that long, but usually last time I had a tutorial this long, it took me like an hour to record all of the voice for this. And yeah, my voice was like giving out by the end of it, but anyway, that's what's on the table for next time. But yeah, I'll be back tomorrow morning at around, well, hopefully a little earlier than today because I got a bit of a late start, but around 10 to 11 US Eastern time, and we'll finish this up. But thanks everybody for coming by. I've really enjoyed chatting with you all, and I hope your projects go well today. And yeah, I'll see you, well, hopefully I'll see you tomorrow, but if not, have a great week. I'll put some links in the chat if you enjoyed the stream and you'd like to connect with me through other social media. Of course, I do have my YouTube channel where I do Unity shader tutorials, and I guess that's it. I'll see you later. Yeah, it's actually afternoon here for me at M2. It's like just after afternoon, so yeah, thank you. I will have a good one, and I hope you have a good day or night as well. All right, I'll see y'all later. Bye-bye.